This video is for the Knowledge Organiser on multiplying standard form. What I would like you to do is read the first page of your Knowledge Organiser, use this video to work through the examples from that page, try the questions from the second page of your Knowledge Organiser, and then complete any Maths Watchwork set. So as I said, what we're going to do today is we're going to multiply two numbers when they are written in standard form, and we're going to give our final answer in standard form notation as well. What we do is we take our first numbers in standard form and we rewrite these so that they are next to each other. What we then do is we take our end parts of our standard form and we rewrite those so that they are next to each other. How we would do this is we would multiply these together because multiplication is commutative. That means that it doesn't matter which order you do it in, and because these are all just multiplied together. And then you would multiply these together. And then we would look at that and simplify our answer. So what I'm going to do is I'm going to look at each step and go through how we would do it and show you a couple of examples. So for 2.4 times 5.2, you would just multiply that how you would normally multiply that. So you could do 24 times 52 and then divide by 100 to put your decimal points back in. But you would get 12.48 for this. Now, when you have 10 to the power of 7 times 10 to the power of 3, previously we have used index laws or indices laws to simplify this. And what we do is we add our powers. So that gives us 10 to the power of 10 because we do 7 add 3. Now, when we were writing numbers in standard form, what you'll notice is our first number must be between 1 and 10. In this case, our first number isn't between 1 and 10. So what we do is we're going to divide that first number by 10. Now, to keep our answer the same, if you've got the number 900, if you divide that by 10 to get that back to where you want it to be, you have to times it by 10. So you've got to do the inverse to the other side. So what we do is we divide this number by 10, which gives us 1.248, and then we times 10 to the power of 10 by 10, and that means that we add an extra 1 into our power, and we get 1.248 times 10 to the power of 11. And what we've done then is we've given our answer in standard form. What I'm going to do is I'm going to run through another couple of examples of this. So what you'll notice here is I've got A, B, C and D. What I want to show you is the front numbers affect your first answer, and this index notation, so the times 10 to the power of 2 times 10 to the power of 3, when they change, they affect your times 10 to the power of something in your standard form. So if we were to work out A, we do 3.5 times 2 times 10 to the power of 2 times 10 to the power of 3. And what happens is when we multiply those together, we get 7. And when we add our powers here, we get 10 to the power of 5. Now, that first number there is between 1 and 10. So I don't have to do anything. That's just my final answer. If we're to look at B, notice the numbers don't change. So we've got 3.5 times 10 times 2, and then we've got times 10 to the power of 3 times 10 to the power of 2. Notice that this time, even though the numbers are written differently, the answer is going to be the same because when we times that by 7, and when we add 3 and 2, we're going to get times 10 to the power of 5 again. So again, answers don't necessarily change too much there. For C, we have 3.5 times 10 to the power of, and I believe that is a 6. I'll just double check that for you. It is a 6 times 10 to the times 2 times 10 to the power of minus 3. So we rewrite that 3.5 times 2 times 10 to the power of 6 times 10 to the power of minus 3. Again, that's going to give us 7, and that's just going to give us times 10 to the power of, and then we do 6 add minus 3, so it's just going to be times 10 to the power of 3. I've just rewrote that. My first line here, the reason why there's an extra line in my working out, is I've just rewrote that because the 6 wasn't very clear. Okay, but we've got, again, the 7 stays the same. Notice 6 add minus 3 is the same as 6 take away 3, so you get 10 to the power of 3. Again, for D, we'll have a look at that. You're going to have 3.5 times 2 times 10 to the power of minus 3 times 10 to the power of 6. And again, that's going to give us 7. Minus 3 add 6 gives us 10 to the power of 3. So notice, even though our numbers are written in a different order, for where our powers have been swapped around for these, the answers give us the same. Okay, so what we do is we put our first numbers in each standard form together, and then we put our numbers to the power of, which are to the power of 10 together, and we add the powers and we times our first ones together. I'll do that again here. So if we have a look at this, we have 3.5 times 3.5 times 10 to the power of 2, and we have 2.8 times 10 to the power of 3. So we do 3.5 times 2.8 times 10 to the power of 2 times 10 to the power of 3. Now, it is up to you how you want to do that 3.5 times 2.8. You could take out, well, what I would do is I would take out the decimal points. I would do 35 times 28, and then I would divide by 100 at the end. If we did that, what you would get would be 9.8. What we then do is we have a look at these here. We add our powers and we do 10 to the power of 5. So what we should find for every other one of these questions, it's going to be 9.8 times 10 to the power of something. And again, our powers are reversed, and I would expect my answer to be 9.8 times 10 to the power of 5 because the powers have been reversed. So we do 3.5 times 2.8 times 10 to the power of 3 times 10 to the power of 2. And it gives us 9.8 times 10 when we add these together to the power of 5. For C, we're going to do 3.5 times 2.8 times 10 to the power of 8 times 10 to the power of minus 3. So again, I'm going to get 9.8. Notice I've left this as 9.8, by the way, for each of these because it's between 1 and 10. But then I do 10 to the power of 8, add minus 3, which gives me 10 to the power of 5. And then again, for this next one, I would expect the answer to stay the same because our indices have just swapped around and we're just going to add them. And when I work them together, or work them out, minus 3 add 5 does give me that. So I'd expect those to stay the same. And I'd expect the first numbers to stay the same because the numerical values in every question stays the same. Can you use this video to complete the questions on your second page of your Knowledge Organiser and any maths watch work set by your class teacher? Thank you.